Vitamin B1, also known as thiamine, plays a vital and often underappreciated role in the body's ability to turn starches into energy. While many people associate carbohydrates with quick fuel, what's less commonly known is that the process of breaking down glucose, the simplest form of carbohydrate, depends heavily on thiamine. This essential nutrient acts as a coenzyme, a molecular assistant that activates enzymes responsible for crucial energy-producing reactions. Without enough thiamine, the body struggles to efficiently convert the carbohydrates we eat into the energy our cells need to function. Thiamine's role begins after starches, such as those found in bread, rice, beans, or potatoes, are digested into glucose in the digestive tract. Once glucose enters the bloodstream and is taken up by cells, it enters a sequence of metabolic steps to release usable energy. A central part of this process is the conversion of pyruvate, a product of glucose breakdown, into acetyl-CoA, which feeds into the Krebs cycle, also known as the citric acid cycle, where the majority of cellular energy, ADP, is produced. This critical transformation requires the enzyme pyruvate dehydrogenase, which in turn relies on thiamine in its coenzyme form, thiamine pyrophosphate, TPP, to function. TPP acts like a molecular key that unlocks the enzyme's activity. If thiamine is lacking, this conversion stalls, leading to a metabolic bottleneck where glucose can't be fully used. As a result, energy production declines, and the body may begin to accumulate pyruvate and lactic acid, which can lead to fatigue, muscle weakness, and even neurological symptoms in severe cases. Thiamine is especially crucial for high-energy organs like the brain and heart, which depend heavily on glucose for fuel. That's why early signs of thiamine deficiency often include mental fog, irritability, and low stamina. Fortunately, thiamine is naturally present in many plant-based foods, particularly whole grains and legumes. Brown rice, oats, whole wheat, and barley are excellent sources because they retain the outer layers of the grain where thiamine is concentrated. When these grains are refined, like in the production of white rice or white flour, most of the thiamine is removed, which is why enriched flour and rice have thiamine added back to prevent widespread deficiencies. Legumes such as lentils, black beans, and chickpeas are also rich in thiamine and offer the added benefit of protein and fiber, making them a well-rounded nutritional choice. What makes thiamine's role in starch digestion especially elegant is how it reflects nature's design. Many foods that are high in starch also naturally contain the very nutrients required to metabolize that starch. Whole grains, for instance, provide both complex carbohydrates and the thiamine needed to help break them down into usable energy. This pairing supports a more balanced and sustainable metabolic response, offering steady energy rather than spikes and crashes. In the broader picture of nutrition and energy metabolism, thiamine stands out as a key enabler. It doesn't provide energy directly, but without it, the body's main energy pathways can't function efficiently. In this way, thiamine transforms starches from simple calories into functional fuel. Ensuring a diet rich in whole grains and legumes not only supports digestive health and cardiovascular function, it also secures the foundation of cellular energy production. By choosing foods that naturally deliver both carbohydrate and coenzyme support, we nourish the body in the most complete and intelligent way.